welcome to TutySpot. In this video, let's discuss elimination of left factoring. Left factoring is a grammar transformation that is useful for producing a grammar suitable for predictive or top-down parsing. A grammar in which more than one production has common prefix is to be rewritten by factoring out the prefixes. Means this left factoring involves restructuring the grammar to eliminate common prefixes in production rules. Coming to the importance of left factoring, when a grammar has multiple production rules for a non-terminal with a common prefix, the parser faces ambiguity during the parsing process. It has to choose between those rules without knowing which one will ultimately lead to a successful phase. Then this left factoring helps in resolving that ambiguity by postponing the decision point, making the parsing process more efficient. Next is elimination of left factoring. For example, in this grammar, A implies alpha beta 1 or alpha beta 2 or alpha beta 3 and so on up to alpha beta n or gamma n. So here there are n beta productions that have the common prefix alpha, which should be removed or factored out without changing the language defined for beta, and an alternate to gamma. So we can factor out the alpha from all the n productions by adding a new A production A prime or A dash. So A implies alpha A prime or gamma n, and A prime implies beta 1 or beta 2, beta 3 and so on up to beta n. From this factored out grammar, A can now derive either a common prefix alpha followed by the new non-terminal A prime or the alternative gamma, and A prime encapsulates the different options that were originally prefixed by alpha. This differs the decision of which alternative to choose until more of the input has been processed. Let's see some examples. First example is, let's consider the grammar S implies IETS or IETSES or A, and E implies B. In the first grammar, we have S implies IETS or IETSES or A. So this is in the form of A implies alpha beta 1 or alpha beta 2 and so on gamma 1 or gamma 2. So compare it with our grammar. A means yes and IETS means alpha, and here we didn't have beta 1, and IETS means alpha, and the rest ES means beta 2 and A means gamma. And rewriting it with the factored out grammar, and the rules are A implies alpha A prime or gamma 1 and A prime implies beta 1 beta 2 and so on. So it gives A means S and alpha means IETS and A prime means S prime or gamma 1 means A. And next rule, A prime means S prime implies beta 1 means epsilon and beta 2 means ES. And the next grammar is A implies B. It doesn't have left factoring. So the productions after left factoring are S implies IETS S prime or A, and S prime implies epsilon or ES, and E implies B. Let's see another example. Consider the grammar capital A implies small a capital A B, or small a capital A or small a, and B implies small b capital B or small b. In the first grammar we have A implies A B or A or A. Comparing with our grammar, A implies alpha beta 1 or alpha beta 2 and so on gamma 1 gamma 2, where A means A and alpha means small a and beta 1 means AB, beta 2 means capital A, and we don't have beta 3 here, so consider it as epsilon, and we don't have gamma here. So rewriting it with our rules, A implies alpha A prime or gamma 1 and A prime implies beta 1 or beta 2 and so on. So it will give A means A implies alpha means A and A prime means A prime, and second rule, A prime means A prime implies beta 1 means AB or beta 2 means A, or we don't have beta 3 here, so consider it as epsilon. And the next grammar is B implies small b capital B or small b. Comparing it with our grammar, A means B, alpha means small b and beta 1 means capital B, and we don't have beta 2 here, so it is considered as epsilon, and we don't have gamma here. So rewriting it with our rules, A means B implies alpha means small b and A prime means B prime, and we don't have gamma. Next, A prime means B prime implies beta 1 means B or beta 2 means epsilon. So the productions we got after eliminating the left factoring are A implies A prime, A prime implies AB or A or epsilon, B implies B prime, B prime implies B or epsilon. Let's consider another example. X implies X plus X or X into X or D, and D implies 1 or 2 or 3. So in the first grammar, we have X implies X plus X or X into X or D. Comparing it with our grammar, A means X and alpha means X and beta 1 means plus X. Alpha means X and beta 2 means into X, and D is the gamma. So rewriting with our rules gives A means X implies alpha means X and A prime means X prime or gamma means D. And next rule, A prime means X prime implies beta 1 plus X or beta 2 means into X. And the second grammar is D implies 1 or 2 or 3. So here we don't have left factoring. So the productions after left factoring are X implies X, X prime or D, X prime implies plus X or into X, and D implies 1 or 2 or 3. Let's see another example. A implies T plus E or T, and T implies int or int star T or within the parenthesis E. Consider the first grammar. We have E implies T plus E or T. Compare it with our grammar. A means E, alpha means T, beta 1 means plus E, and alpha means T, and we don't have beta 2 here and we don't have gamma here. So beta 2 and gamma are considered as epsilon. So rewriting it with our factored rules, A means E implies alpha means T and A prime means E prime, and we don't have gamma. Next, A prime means E prime implies beta 1 means plus E, and we don't have beta 2, so epsilon. And in the second grammar, we have T implies int or int star T or within the parenthesis E. So compare it with our grammar. A means T, alpha means int, and we don't have beta here. And next, alpha means int and beta 2 means into T, and gamma means within the parenthesis E. So rewriting with our rules, A means T implies alpha int, A prime means T prime or gamma means within the parenthesis E. And next, A prime means T prime implies beta 1 means epsilon or beta 2 means into T. So after eliminating left factoring, the productions are E implies T E prime, and E prime implies plus E or epsilon, and T implies int T prime or within the parenthesis E, and T prime implies epsilon or into T. So this is all about left factoring and elimination of left factoring. For practice, consider the grammar. S implies ASSBS or ASASB or ABB or B, and eliminate left factoring, and let me know the final grammar in the comment section. Thank you.